G'day students. In the last video we revised how to expand quickly a square of a sum and a square of a difference. So as we've done with all the other special forms, we can also factorize. So if we have an expression that fits that pattern in expanded form, we can write it in the factorized form as a plus b all squared. Similarly, if we have the pattern a squared take 2ab plus b squared, in factorized form we can write it as a subtract b all squared. So probably the hardest thing about doing this is to make sure that an expression fits that pattern. So let's have a look here at x squared plus 6x plus 9 and figure out if we can actually use these patterns up here to factorize it quickly. So what we have to do first is work out what a and b are. So we think if a squared is x squared, a must be x. So a is equal to x. If b squared equals 9, so if that equals b squared, b must be 3. So we know that a is x and b is 3 from those two terms. So the key is the middle term 2ab. So we have to just mentally think, well, 2 times x is 2x, times 3 is 6x, and it does check. So what we've done is we've worked out that if a equals x and b equals 3, then 2ab, in fact, is 6x. So therefore, that is a perfect square. And then the easy step now is that's just a plus b all squared. So the hard step here is working out if it fits the pattern. If it doesn't, we've got to use a different method, which you'll learn about in year 10. If it does fit the pattern, we can just write down the factorized form. So each of these, in fact, is a difference. Sorry, yeah, can be written as a square of a sum or square of a difference. But I want you to go through and actually test it for yourself before you actually factorize it. So let's have a look at the first expression just here. Is this the form a squared plus 2ab plus b squared? Well, if it is, a equals x and b equals 4. So what we really have to work out is what is 2ab? Well, if a is x, that's 2x. If b is equal to b squared is 16, b is equal to 4. And 2x times 4 is 8x. So it does check. And therefore, we can now write the answer. Oh, sorry, not the answer, but the factorized form, just a plus b all squared. So the tricky bit is working out if it actually fits the pattern. Okay, let me try this one down here. Then you can have a go at those two. So in this case, a squared is x squared, so a is equal to x. B squared equals 1, so b is equal to 1. So we've got to work out what the value of 2ab is. Well, that's going to be 2 times x times 1, which is 2x. So yes, it does check. So in factorized form, that's just going to be a plus b all squared. Okay, go ahead and do the same thing for those two, please, and then check your answers. Okay, let's see how you fared. So a is equal to x, b is equal to 5. What's 2ab? By the way, after you've done a few of these with paper and pencil, hopefully you can start to just do the check mentally. 2 times x is 2x. Times, if b squared is 25, b is 5. 2x times 5 is 10x. Yes, it works. We don't worry about the fact that it's negative 10x. That just means it's a square of a difference, so it's just going to be x take 5 all squared. So that's the expanded form. That's the factorized form. Okay, and the last one. So a is equal to x, b is equal to 6. If that's the case, what does 2ab equal to? Well, 2 times x is 2x. And if b squared is 36, b is 6. And that gives us 12x. So it does check. And therefore, because this is a perfect square, or a difference of two squares, it's just x takes 6, in brackets, all squared. So we're going to use that to help us solve some quadratic equations in the next video.